After you've removed the shell, and if you have a digital food scale at home, you can find the mass of the egg. You will then record this mass as the initial mass. You will then take that egg and put it into a cup labeled water. You'll do that same process for your second egg. Find the mass, record it as your initial mass, and then this time put it in a cup labeled syrup. For your water cup, just fill it up with water till the egg is submerged. And for the syrup, submerge the egg in syrup. So fill it all the way up until it covers the egg. Notice how the egg rises to the top of the syrup, but the egg in the water stays below. What would that tell you about the density of the syrup as compared to the density of the water? Additionally, what would that tell you about the solute concentration? Which one probably has a greater solute concentration? At this point, we'd like you to go ahead and pause the video and make a prediction. So what's going to happen to the eggs after they're sitting in their various solutions for 24 hours? Will the mass of the egg increase or decrease in the water, and why? And will the mass of the egg increase or decrease in the syrup, and why? When making your prediction, think about the solute concentration of movement of water. Which side is hypertonic, which side is hypotonic? Remember that water always moves towards the hypertonic side of a membrane. This is what the eggs look like after sitting in their solutions for 24 hours. I'm going to first take out the egg out of the water cup and then blot it dry on the paper towel. Notice how squishy it is. Once you've gotten a majority of the water off, go take it to your balance and find that final mass. And don't forget to record that in your data table. You're going to do the same thing with the egg in the syrup cup. This one is a little messier. Feel free to use a spoon if you want. Notice how deflated the egg looks. And then you're going to just blot it off and try and get as much of that syrup off the outside of the egg as you can. You're then going to do the same thing again, find the mass, and record that as your final mass for your syrup egg. If you don't have a scale for quantitative observations, you can certainly look at qualitative observations. Notice how deflated the syrup egg looks and how full the water egg looks. What would that tell you about the movement of water? Which way did it go? Fun test is to bounce the egg on your counter. What happens to the one full of water versus bouncing the syrup egg? So what did we learn in this lab? We learned that water moves through a membrane from an area of low solute concentration to an area of higher solute concentration. This was demonstrated by the egg that was placed in the water. It gained mass, which means that water must have moved into the egg. And the egg that was in the syrup lost mass, which means that water must have left the egg. So we can say that the egg in the water was hypotonic, and then the egg that was in the syrup was hypertonic.